Some elements explode in water, others glow in the dark, and some are so rare they barely exist on Earth. But what makes them different? Let's break down the periodic table into four major blocks and uncover their secrets. Welcome to Study Crunch, where we make learning science fun. If you love chemistry, hit that like button and subscribe. First up, the S block, the home of the most reactive elements in the periodic table. It includes two groups. Group 1, alkali metals, lithium, sodium, potassium, super soft, highly reactive, and they explode in water. Group 2, alkaline earth metals, magnesium, Mg, calcium, Ca, barium, Ba, less reactive but still important for bones, fireworks, and metals. Properties of S-block elements, highly reactive, especially alkali metals, which must be stored in oil. Good conductors, excellent for batteries and electronics. Low density, lithium is light enough to float on water. Found in biological systems, sodium and potassium regulate nerve signals, while calcium strengthens bones. Example, drop sodium into water and it reacts violently, releasing hydrogen gas and heat. Fun fact, magnesium is the reason fireworks burn so brightly. Next, we have the P block, home to metals, nonmetals, and noble gases. It contains groups 13 to 18, including essential elements like carbon, oxygen, and fluorine. Properties of P block elements, highly varied, includes both metals and nonmetals. Essential for life, carbon forms all living things, and oxygen keeps us alive. Halogens, group 17, are the most reactive nonmetals. Fluorine is used in toothpaste, and chlorine disinfects water. Noble gases, group 18, don't react. Helium, neon, and argon are stable and used in lighting and cooling. Did you know? Silicon Si powers computer chips. Fluorine F in toothpaste strengthens teeth. Neon makes bright glowing signs. Example, ever wondered why balloons float? That's helium, an unreactive noble gas. Now let's talk about the D block, also known as the transition metals, the backbone of industry, technology, and even your own body. These are found in groups 3 to 12 and include iron Fe, the most widely used metal found in buildings and even in your blood. Copper Cu and silver Ag, excellent electrical conductors used in wires and jewelry. Gold are Au and platinum, Pt, rare, non-corrosive, and valuable in electronics and jewelry. Titanium, Ti, and chromium, Cr, lightweight yet super strong, used in aircraft and stainless steel. Properties of D-block elements, strong and durable, essential for construction and machinery, great conductors, used in electrical wiring and circuits. Often colorful, transition metals form vibrant colored compounds used in paints and dyes. Can have multiple oxidation states, making them useful in chemistry and catalysis. Fun fact, iron makes your blood red. Gold is the most non-reactive metal. It never rusts. Chromium is what makes rubies red and emeralds green. Example, without D-block metals, there would be no skyscrapers, no smartphones, and no modern technology. Finally, the F block, also known as the lanthanides and actinides. These are the rarest and most powerful elements in the periodic table. Lanthanides, rare earth metals. Neodymium, Nd, used in powerful magnets for headphones and hard drives. Europium, Eu, and terbium, Tb, found in smartphone screens and LED displays. Actinides, radioactive metals. Uranium, U, and plutonium, Pu, used in nuclear power and space probes. Thorium, Th, a potential future energy source. Properties of F-block elements, mostly radioactive. Some are naturally occurring, others are man-made. Used in high-tech industries, found in smartphones, lasers, and spacecraft. Can be dangerous. Actinides emit radiation, making them both useful and hazardous. Fun fact, neodymium magnets are in every pair of wireless earbuds. Thorium reactors could be the future of clean nuclear energy. Example, uranium fuels nuclear submarines and even space probes. So now you know the 4 blocks of the periodic table. Which one fascinates you the most? Let me know in the comments. If you learned something new, smash that like button. Subscribe for more amazing science content.